So hey everyone, in this video we are going to look at the question all paths from source to target. We are given a graph and we are asked to return all the paths, all the possible paths from 0 to n minus 1 node. So in this example, you can see there are two paths from 0 to 3, 0, 1 and 3 and 0 to 2 to 3. The input represent the graph in this order. The index will be that current node and the array at that particular index represent the connected node. So for index 0, we have 1 and 2 in the array. So that means element 0 or node 0 is connected to node 1 and node 2. So this is the question. Let's see how we can do it. So in this particular case, we need to return all the paths from node 0 to node 3. So what we can do, we can maintain two arrays here. So one will be the result array, which will be our final output array, and the other will be our path array, which will be representing our current path. By path, what do I exactly mean? We'll see just now. So what we'll do, we'll just run a normal DFS here. So we'll start from the node 0 and we'll push the node 0 to a path array for now. Now from node 0, we'll run a DFS and we can go to either node 1 or node 2. So let's start from node 1. When we come to node 1, we'll add this node 1 in our path array. So in our path array, till now it will be 0, 1. Now from node 1, we'll run the DFS again. So from node 1, we can go to node 3. So once we reach node 3, we'll add this one to the path array as well. So the path array will become 0, 1, 3. Now, once we have reached the node 3, we have fulfilled our condition. We have found one path from node 0 to node 3. So we can just push this one to our result array. So the first path we have found is 0, 1, 3. Now from 3 we cannot go anywhere. So back to 0. Now the other connected node to 0 is 2. So when we come to 2, we'll add 2 in our path array. So this time it will be 0, 2. So next path is 0, 2. Now from 2 we can go to node 3. So once we reach node 3, we'll add 3 to our path array as well. So the path will become 0, 2 and 3. Again we have reached our base condition that we have reached node 3 and we'll add this one to our result array as well. So it will be 0, 2, 3. So this will be the approach. Let's see how we can do it in code. So let's just declare our variables first. So result for our final output array. Let's also declare a variable for our end node. So it will be graph.length -1. Let's define our DFS function as well. It will take our current node, our path, and inside this DFS function, first thing we need to check if our node is equal to the end node. If that is the case, that means we have found our path and we need to push it in our result array. So we'll push path in our result array. If that is not the case, we need to run DFS on all the neighbor nodes. So for that, we'll write for const neighbor node of graph at that particular node, and we'll call our DFS function again, passing the neighbor node and the new path, and the new path will be the previous path plus the neighbor node. Now outside, we'll just call our DFS function passing 0 as the starting node and the initial path with 0 as the first node in it. And at the end, we'll just return the result array. So if we run this, it's working. Let's submit it. Good. So that was it for this video. Thank you for watching.